Welcome to Godwin. Today we're looking into the anatomy of the human kidney. So in today's topic, we'll be talking about the external anatomy of the kidney. So in later videos, we'll be looking into the internal anatomy of the human kidney. So there are two kidneys in the human body. We have the right kidney and the left kidney. So the kidney is bean shaped, it is reddish brown in color, and the average human kidney weighs about 120 to 200 grams. Okay, the average human kidney weighs for 120 to about 200 grams. So this is the average weight of the human kidney. Okay, the human kidney is located in the posterior abdominal wall behind the peritoneum. So it is an extraperitoneal organ. All right. So as I said earlier, we're looking at the external anatomy of the human kidney. All right. So before we start looking into the external anatomy of the human kidney, let's talk about the function of the kidney. What is the function of the human kidney in the human body? All right. So from the structure here, we can find the right kidney and the left kidney, and this is the renal pelvis and the ureter. All right. One of the main functions of the human kidney is the production and excretion of urine. All right. So the kidney helps us to produce urine and to also excrete this urine out. Okay. We're looking at the process of urine formation in later videos, but let's talk about now the function. Now it produces urine. So this urine are produced, passed into the renal pelvis, then continues with the ureter and now into the urinary bladder, where it is temporarily stored before micturition, and now it is passed out through the urethra. This is the prostatic part of the urethra, and it continues out. Now, that is one of the functions of the kidney. The other function of the kidney is that the kidney helps us regulation of the amount of water in the human body. Now, this is one of the main functions of the kidney. So when we're talking about renal physiology, we look more into the function of the human kidney. So now let's talk about the external anatomy of the human kidney. All right. From the diagram here on the board, we find out that the kidney has two poles, two surfaces, and also two borders. So it has two poles. These two poles are the superior pole, the inferior pole, the medial border, the lateral border, and anterior and behind it a posterior surface. So it has two surfaces, two poles, and two borders. All right. So here we have the superior pole. The superior pole. The superior pole is directed superiormedially, okay, and it is thin compared to the inferior pole. The inferior pole lies here, inferior pole, and it is very, very thick. The inferior pole of the kidney is thicker than the superior pole. The kidney has a medial border, so this is the medial border. And here we have the lateral border of the kidney, the lateral border, which is here, lateral border. All right. So this is the lateral border of the kidney, the medial border of the kidney, this superior pole and inferior pole. It has an anterior surface and behind it a posterior surface. So these are the surfaces, borders, and the poles of the human kidney. So before we move more into the external anatomy of the kidney, let's talk about the skeletotopy of the kidney. How does the kidney project on the human skeleton, posteriorly and anteriorly? All right, the human kidney, since we have the right kidney and the left kidney, from the diagram here you can see that the right kidney is slightly bit lower than the left kidney. This is because the liver also lies in that same region, so it kind of pushes the right kidney a little bit downwards. All right, so the right kidney lies about 1 to 1.5 cm below the left kidney. So the right kidney lies about 1 to 1.5 cm below the left kidney. All right. So the right kidney lies about 1 to 1.5 cm below the left kidney. All right. So let's talk about now the skeletopy behind, posteriorly. Now, since the right kidney lies a little bit lower, which means it lies on the vertebrae T. It lies, this is the right kidney, and this is for the left kidney. All right. So the right kidney and the left kidney. So here we're talking about their skeletotopy. All right. So the total length of the kidney is from T12 to L3. From T12 to L3. All right. So let's see now which kidney lies on T12 to L3 and which one lies on T11. All right. Now the right kidney, because it is lower in the human body, it lies on vertebrae T12 and continues to L11 to L3. Okay, it continues to L3 from thoracic vertebrae 12 to the lumbar vertebrae 3 because it is lower in the human body. So it lies on thoracic vertebrae 12 and the third lumbar vertebrae. Now the left kidney, because it is higher up, it lies on the thoracic vertebrae 11 and ends at the lumbar vertebrae 2. So this is the difference in their projection on the human skeleton. So this one lies on the thoracic vertebrae, and from the superior thoracic vertebrae L11, then ends at the lumbar vertebrae 2. This one starts from T12, then ends at L3. All right. So this is how they project on the skeleton posteriorly, or on the vertebral column posteriorly. Now let's talk about now how they project anteriorly. How does this kidney project anteriorly? Now, anteriorly, the right kidney is crossed because it is lower in the human body. It is crossed by the 12th rib at the superior pole. So the 12th rib crosses the right kidney at the superior pole. At the superior pole, 12th rib. So the 12th rib crosses the right kidney at the superior pole. Why the left kidney, it crosses it at the middle. So the 12th rib crosses the left kidney at the middle. Alright, so this is how they project on the skeleton anteriorly and posteriorly. Now, let's talk about something different from here now. Assuming, okay, look at this diagram here. This is the right kidney and this is the left kidney. So the distance from the iliac crest, the distance from this right kidney or both kidneys from the iliac crest ranges from about 3 to 5 cm. So the distance from the inferior pole of the kidney down to the iliac crest is about 3 to 5 cm. So this is the distance from the iliac crest. This also is the distance between the left kidney and the right kidney. So between the right kidney and the right kidney is about 1 to 1.5 cm below the left kidney, and the kidney lies about 3 to 5 cm above the iliac crest or away from the iliac crest. So this is the skeletotopy of the human kidney. So let's now talk about the kidney support system. What supports the kidney? What holds the kidney in place in the human body? All right. So there are several kidney support systems, and the first we're going to be talking about now is the renal bed. The renal bed, like a bed where we lie on. All right. The renal bed is just an excavation in the posterior abdominal wall where the kidney lies. Assuming this green marker here is the kidney, and this is the posterior abdominal wall. All right. So this lies here. So this is the renal bed where the kidney lies. So it's like a slight excavation in the posterior abdominal where the kidney lies. All right. So which means there are muscles in the posterior abdominal wall that houses the kidney. All right. So these muscles are the psoas major, which lies medially. All right. So let me write the renal bed somewhere here. All right. Kidney support system. Kidney support. All right. First one is the renal bed. Renal bed. So as I said earlier, the renal bed consists of the psoas major and the quadratus lumborum. The quadratus lumborum lies laterally, while the psoas major lies medially. So let's write the psoas major here. So the renal bed consists of the psoas major and the quadratus lumborum. Alright, so the renal bed consists of now the psoas major and the quadratus lumborum laterally and the psoas major medially. Alright, now let's talk about now a very important structure of the kidney, which is called the renal capsule. The renal capsule is also a support system or a supporting structure of the kidney. The renal capsule. Renal capsule. Alright. The renal capsule is a connective tissue that surrounds the kidney. The renal capsule is a connective tissue that covers the kidney. Okay? It can actually be peeled off, but in some kidney diseases, it sticks together with the kidney. Okay? So it can actually be peeled off. So it surrounds the kidney, and it is, as I said earlier, it's a connective tissue, and it contains some nociceptors, some pain receptors. Okay, some pain receptors. That's why I find out that injury to the kidney or any disease of the kidney may cause some excruciating pain because of the nociceptors that are found in the renal capsule. All right. So I will draw the renal capsule with the green pen. All right. So the renal capsule is just like this, surrounding the kidney. All right, so this is the renal capsule. It covers the kidney. All right, so it's a supporting system of the kidney. So the next kidney supporting structure we're going to be looking at now is the perinephric fat. Perinephric fat. The perinephric fat. The perinephric fat is some fat tissues that covers the kidney. Some fat tissues that covers the kidney. All right. So before that, remember, in the medial border of the kidney, we have the renal hilum and the renal sinus. Okay. So this is the medial border of the kidney, where we have the renal hilum and the renal sinus. All right. So in the renal sinus is just here. Okay, it contains fat tissues also. Okay, it contains fat tissues also, and also contains some lymphatic vessels and nerves. All right, the perinephric fat invests also into the renal sinus, so it continues with the fat in the renal sinus. So the perinephric fat continues with the fat in the renal sinus. Remember, in the medial border we have the renal sinus and also the renal hilum. The renal hilum is just an excavation in the medial border of the kidney, where the renal pelvis and the renal artery and vein also comes into the kidney. All right. So the renal sinus also contains the calyces, the major and the minor calyces. All right. So this is the perinephric fat. All right. So I'm going to be drawing the perinephric fat in the red pen. So I'm going to be drawing the perinephric fat in the red pen. So the perinephric fat lies superficial to the renal capsule. The perinephric fat lies superficial to the renal capsule, as you can see from the diagram here. All right. So this is the kidney support system. So the next kidney supporting structure we'll be looking at now is the renal fasciae. The renal fasciae. The renal fasciae. The renal fasciae covers the perinephric fat and also covers the kidney. Okay, so this is the renal fasciae. It anchors the kidney to different structures in the human body. It holds the kidney in place. All right. So there are two layers of this renal fascia. We have the pre-renal fascia and the post-renal fascia. All right. The pre-renal fascia is also called the Gerota's fasciae, and the post-renal fascia, which lies posteriorly, is called the Zuckerkandi's fasciae. All right. Let's look at this diagram here. This diagram here. All right. We have the pre-renal fascia. All right. So the renal fascia is divided into two layers: the pre-renal fascia of Gerota's fasciae and Zuckerkandi's fasciae, which is the post-renal fascia. The pre-renal fascia of Gerota's fascia covers the kidney anteriorly. Okay, it covers the kidney anteriorly. As you can see from this diagram, this is the abdominal aorta, and this is the inferior vena cava. So between the vertebrae L1 and L2, the abdominal aorta gives off the renal artery, which branches into the kidney. All right. So this is the how the renal artery comes off from the abdominal aorta and the renal vein from the inferior vena cava. Now, the pre-renal fascia covers the kidney anteriorly, so it crosses medially over what the inferior vena cava and also crosses to the abdominal aorta. So it continues with the pre-renal fascia of the opposite kidney. It continues medially. It continues with the pre-renal fascia of the opposite kidney. All right. Now, laterally, what happens laterally? Laterally, it joins with the post-renal fascia. It joins with the post-renal fascia, also called the Zuckerkandi's fascia. So let me just write the other names of these fascias. So pre-renal fascia. So renal fascia is divided into two layers. Okay, we have the pre-renal fascia, also called Gerota's fascia, and have the post-renal fascia, also called the Zuckerkandi's fascia. Zuckerkandi's fascia. Zuckerkandi's fascia. Zuckerkandi's fascia. All right. So the pre-renal fascia merges laterally with the post-renal fascia to form another type of fascia known as the lateroconal fascia. All right. So there's a different type of fascia which is formed laterally, known as the lateroconal fascia. All right, the lateroconal fascia. So you find out that now these fascias, they merge, they continue medially and also laterally. Superiorly, they also merge superiorly. Remember, so at the superior pole of the kidney lies the suprarenal gland. Also lies the suprarenal gland. So they continue superiorly, and they merge together also with the posterior renal fascia. All right. Inferiorly, these fascias do not merge together. Inferiorly, do not merge together. So that is why I see that in some situations we have nephrotosis where this kidney descends below normal, below the normal descent it has. All right. So this is the kidney supporting structure, and these are the anatomy of the kidney, external anatomy of the human kidney. In some situations, this kidney, the right kidney, may descend abnormally. We call it the abnormal kidney descent or nephrotosis. All right, where the kidney now descend and is found now in the greater pelvis. So in this is actually usually called by, let's say, loss of abdominal pressure, all right, or loss of perinephric fat, which is common in weight loss. Okay, so the kidney might descend abnormally into the greater pelvis. So it has now to be sutured to the posterior abdominal wall, to the contractus lumborium and the psoas major by a surgeon known as nephropathy, by using non-absorbable sutures. All right. So in some situations, now remember, from the abdominal aorta, okay, the superior mesenteric artery comes off from the abdominal aorta, and the left renal vein lies between, let's say this is the superior mesenteric artery. Let me just draw it here. All right. Let's say this is the superior mesenteric artery, SMA. All right. Now, you find that the left renal vein lies between the abdominal aorta and the superior mesenteric artery. In some situations where there's a downward traction of this superior mesenteric artery, you find that one, it will press against the renal vein. It will press against the renal vein. And you remember, the testicular vein comes off from the left renal vein. Comes off from the left renal vein. So this may cause pain to the left testis. May cause pain to the left testis because there is pressure on the left renal vein. This is known as the Notch-Kaczor syndrome. The Notch-Kaczor syndrome. All right. So this is the external anatomy of the human kidney. So in the next video, we'll be talking about the internal anatomy of the human kidney. We're looking at some deep structures of the human kidney and how this urine is being formed, or how the artery branches into the kidney. Remember, in this video we didn't talk about how the arteries and vein branches into the kidney. So we're looking at the renal segmentation, the nephrons, and other parts of the internal anatomy of the human kidney. So please, if you've not subscribed to this channel, please subscribe to this channel, like, share, and also leave a comment in the comment section below, and I will see you guys.